today's section we discuss about the fuzzy logic controller. So fuzzy logic control is also, which is called as an FLC, is a most active research area in the application of fuzzy Z theory, fuzzy reasoning, and fuzzy logic. And as discussed earlier, we know that fuzzy logic control has been used in the n number of applications. Okay, that is, it extends from industrial process control to all the biomedical instrumentation or any biomedical securities, biometric security. So this fuzzy logic control we are using in we are using in all the reasoning applications. So compared to conventional control techniques, FLC has been best utilized in complex ill-defined problems which can be controlled by an efficient human operator without knowledge of their underlying dynamics. So it is like a neural network. So neural network, which we cannot able to, there is no need of human power there. Okay, so artificial intelligence or neural network will automatically identify the problem without an efficient human operator. So like that, fuzzy logic control is also a technique which comes under the various applications. So coming to the architecture and operations of FLC system. So in the forthcoming figure, it has been defined. So the principal components of an FLC system is a falsifier, fuzzy rule base, a fuzzy knowledge base, an inference engine, and the defalsifier. So as already in the previous sections, I have defined about a falsifier, defalsifier, and inference engine. So all these components has been explained clearly in the previous sessions under the topic of falsifier and defalsifier. It also includes parameters for normalization. When the output from the defalsifier is not a control action for a plant, then the system is a fuzzy logic decision system. Okay, so the falsifier present converts crisp quantities into a fuzzy quantities, and whereas the defalsifier is going to revert, like it will convert the fuzzy quantities into a crisp quantities. So the fuzzy rule base stores knowledge about the operation of the process of domain expertise. And also it stores the knowledge about all the input output fuzzy relationships. So it includes the membership functions defining the input variables to the fuzzy rule base and the output variables to a plant under control. And we are using inference engine in between the falsifier and the defalsifier. It is a kernel of the FLC system and it possesses the capability to simulate human decisions by performing approximate reasoning to achieve the desired control strategy. And the defalsifier converts the fuzzy quantities into a crisp quantities from an inferred fuzzy control action which is done by the inference engine. So coming to the block diagram of this fuzzy control logic, that is FLC, you can see the input is given to the normalization input scaling factors, and it is scaled like x1 because you know x1 as an set, that is input set, and x2 is an output set, and it is processed with the falsifier where the fuzzy knowledge base is connected, and again it enters into the interface or inference engine, then it goes to the defalsifier and finally to the plant. So the output has been given, and again it is feedbacked. It is something which is called a feedback loop. So the output, the part of the output is sensed here, and again you're going for the normalization output scaling factors to give an input to the falsifier. So it is a repeated process. It is a feedback process where you can get various outputs or the states. So step one is, that is what I said, you're going to locate the input, output and state variables of the plane under consideration. And then you are going to split the complete universe of discourse that is spanned by each variable into a number of fuzzy subsets, assigning each with a linguistic label. And also you can going to obtain the membership function for each fuzzy subset. Assign the fuzzy relationships between the inputs or the states of the fuzzy subsets on one side and the output of fuzzy subsets on the other side. So thereby forming the rule base. So you're going to choose the appropriate scaling factors for the input and output variables for normalizing the variables between, because I said that 0 to 1 interval, or we can take -1 to 1 interval also, and carry the falsification process, then inference process, and finally defalsification to form a crisp output. Applications of these systems include traffic control, steam engine, aircraft flight control, missile control, adaptive control, liquid level control, helicopter model, automobile speed controller, braking system controller, process control. So these control, all the control, like even if you go for the automobile or thermal control, or you go for the traffic control. So wherever you need to go for any control, nowadays we can use fuzzy logic control. So these fuzzy logic control system has been adopted in each control. It's not only limited to those controls. You can go for extended like robotic control and lift control, even in automatic lift control like elevator. So all those things also you go for the fuzzy. Like when you enter it will on. So when you just leave the lift it will off like that. So it is you are wasting the power, no? So here you are going to save the power. You are using it properly. So everything is you are going to use a sensor to sense it, and automatic running control, cooling plant control, water treatment, boiler control, nuclear reactor control, power systems control, air conditioner control, like temperature controller. Even in AC also you are using temperature controller, right? So automatically it will sense the temperature, and according to that it will on the AC. So that there also you are using a fuzzy. It's like IoT only, Internet of Things only. And then biological processes, knowledge based system, fault detection control unit. So this fault detection control unit has been used in all the units, like all the plant we are using, like yeah, even we are using in the automobiles also. If you using how to you're going to verify the car operation of the car, then if any fault is there before entering into the valuation, they will check the fault and they will detect it. So fuzzy will do that. And then finally fuzzy hardware implementation, also fuzzy computers. So these are the number of applications where it involved. So thank you. We will see in the next session.